Now that we've looked at tangents, let's have a look at normals. First of all, what is a normal? Well, a normal would be, on any function, information about a specific point. Now, looking at a specific point, like we did with the tangent, this would be the tangent with the slope of the rate of change at that point. The normal, on the other hand, is the perpendicular line to that point, which would be this one here, where the value in here is 90 degrees. The normals are very important things to calculate in physics. So, how do we calculate the equation for the normal? Well, we do roughly the same steps. We make sure that we find both x and y. We find the derivative of the original function. And we use our original value of x to put in to our derivative. This is where things start to change. For step 4, we need to calculate the slope of the normal. The slope of the normal is given by the negative 1 over our calculated derivative. After that, we can then put it into our equation for the straight line, which is y minus y1 equals m outside of x minus x1. Now let's look at an example. So, looking at the equation y equals 9x squared plus 6, and we're going to find the normal at the point 2, 42. So in this case we have our value for x and our value for y, so we don't need to calculate either of them. So the next step is to calculate the derivative, which is going to be equal to 18x. Now that we have our derivative, we need to calculate it when x equals 2, which is given by 18 times 2, which is 36. Now, the slope of the normal is given by the negative 1 over 36, the value that we found at our point. Now we have all the information we need to calculate the equation for the normal. The equation is given by y minus y1 equals m outside of x minus x1. Now we'll just go and grab all the details that we need. So y minus 42 equals minus 1 over 36 outside of x minus 2. Solving this equation, we get y equals minus x on 36 plus 2 on 36 plus 42, which we can then simplify to being 36y equals 1514 minus x. Now this is our equation for the normal, so the perpendicular to the tangent at the point 2, 42.